In this section, we're going to talk about the intersection of evolution and modern society. And I like to start with this picture. This is kind of a humorous take of a very famous diagram that's had a lot of discussion and some controversy over the years called the progress of man. This is a humorous take, and the idea here is that we show a progression, right? A change. So we're trying to show some form of evolution. Now, I like asking students the question, what's wrong with this picture? And I don't know which is more troubling, the guy with the rake or the jackhammer or the guy on the computer that don't have any clothes on. But what I mean when I look at this is there's something as an evolutionary biologist that just kind of jumps out as me as immediately incorrect. And some people will say, well, there's this idea of de-evolution, right? Of going back to something similar to a former state. And that doesn't really bother me as an evolutionary biologist. In fact, change is change, and that's all evolution. And there really, other than maybe if we have a very biased point of view, there's really no such thing as evolving versus de-evolving. It's all evolution because we're all changing. But the problem that I have as an evolutionary biologist with this image is on the far left, we have an organism that, at least to me, as from my area of expertise, looks like a chimpanzee. The species is Pan troglodytes, and so we are implying here that a chimpanzee evolves and turns into, I don't know, maybe this is supposed to be Homo habilis. Actually, it looks a little bit different than that, even farther along than that. But we have a change of a modern species into an ancient species. And then, of course, going towards man. And in fact, if we say that humans evolved from chimpanzees or humans evolved from monkeys, that's an incorrect statement. So this is problematic. Now, perhaps the artist didn't intend this to be a modern species, maybe meant it to be a representation of an extinct organism that was, at least in my head, very, very similar to chimpanzees, which is probably not the case for our common ancestor. And so the key here is that humans did not evolve from chimpanzees or any other modern primate species. However, what evolution does say is that we share a common ancestor with chimpanzees. However, and this is a key underlying principle of evolutionary theory, is that we and all other living organisms share a common ancestor with every species on Earth. And the reason that we are more similar to chimpanzees than we are to, say, a penguin is because the common ancestor that we share with chimpanzees is more recent than the common ancestor that we share with a penguin. But we still share an ancestor. And no matter what species it is, if it is a shark, humans and all other species share a common ancestor with sharks. We share a common ancestor with insects. It's farther back. We share a common ancestor with mushrooms. We have to go even farther back. And so the more taxonomically distant we get, the more ancient our common ancestor with those species is going to be. But we share a common ancestor with all life on Earth. There's a common origin. Okay, so that is a key tenet of evolutionary biology, and it contradicts, the implication of this diagram that we did not evolve from chimpanzees, although we are related to them. But we're related to mice, we're related to frogs, we're related to trees, we're related to bacteria. If it's alive, we're related to it, and all species are. Okay? Now, historically, there have been some controversy about evolution in the American culture. And America, amongst industrialized nations, kind of falls on the low end. And this is a bit dated, but it probably would be somewhat similar today. The low end about the acceptance of evolution across society. So this was a poll that was taken where they asked people essentially, do you believe in evolution? And in the US, about 40% said yes, I would believe that's a true thing. About 40% said no, it's false, and about 20% were uncertain. And notice in other countries it's a little bit more skewed, where there's a little bit wider acceptance. Now, it's been an issue in American culture for a couple of reasons. Number one, there's been some miscommunication, or perhaps a better term might be kind of poor science education. So some people really don't understand the idea of evolution. And then number two, there are some cultural forces, particularly religious forces, that sometimes see a conflict with what evolution is saying and those deeply held personal beliefs. Now, we're going to talk and address both of these. Now, I'm not going to have time to go into great detail in everything. We'll give you some guidelines and some key historical events that in the American culture that deal with evolution and bumping into religion. But if at any point you want to discuss this further, you want to make an appointment with me, you want to send me an email, send me a link, I'm more than happy to do that. If you want to talk about your specific beliefs and where they coincide or maybe even perceivedly conflict with what we're talking about evolution, that's great. If you want to do it, I'm happy to do that, and I can do it in much more detail with you. My personal point of view is that there is room and a role for both religion and evolution, science in general, but evolution specifically, especially for this course. There's a role for both in our lives. That's my personal choice and my personal view. Yours may be different. You might be very, very strongly religious and have some major questions in your mind about evolution. That's okay. You might be a skeptic or an atheist and say, I don't believe in God, or I'm a little skeptical about that, but I really strongly believe in science and evolution, and that's fine too. No matter where you fall on that spectrum, in this class, we are going to talk about science, how it works, what it is, especially the biological sciences, and you're going to learn the data and the details that support the idea of evolution. But my point is that you don't necessarily have to choose one or the other. That there is room for both, and both may provide some value, and certainly across a wide spectrum of society, there's a valuable role and a especially historical and even today for both science, including evolution, and religious pursuits. Okay, now we're going to start with a simple definition of creationism. Creationism in general is an appeal to a supernatural force when we're talking and trying to explain the origin of the universe, or maybe more narrowly, the origin of our Earth. Now, there is a fairly narrow form of creationism that is most common in U.S. society, and this is kind of the Judeo-Christian Muslim. They're all very, very similar. Idea of a supernatural being creating the Earth and that religious tradition. But really, you know, there are hundreds and hundreds of different creation stories from different cultures, and all of them have the same thing in common, is that they appeal to a supernatural, or basically something that we cannot explain using our limited senses and using our understanding of the universe. So we appeal to a power beyond ourselves. Now, science, on the other hand, is a system or a strategy to try to understand how the world around us works. And we're not going to go into a lot of detail about it, but I do want to emphasize, maybe re-emphasize, because you should have learned this in other classes, but emphasize some components of science, okay? So science is simply a way to test and check to have a good idea about how the world around us works. And science has lots and lots of valuable input and has had a major, and continues and will in the future going forward, have a major impact on our society, our quality of life, the way our world works. Now, you have two reading assignments for this chapter. One is by a very famous evolutionary biologist named Theodosius Dobzhansky, and he talks about evolution as a key component for all biology. So read that, go over it. There's a question also that you need to answer and turn it in. The second paper is by this man, who's Stephen Jay Gould. Stephen Jay Gould was a great science communicator, very well-established and well-respected scientist, and he was interested in talking to the general public and helping them to understand science and specifically evolutionary biology. And the second reading that you have, paper number 2, is a short letter that he wrote where he talks about a strategy for allowing both religion, or if you want to say metaphysical endeavors, parts of human society, to play a role and do what they do well, and also allow science. And his idea was this idea of separate magisteria. And this is an idea that he kind of borrowed from the Catholic Church, but this is idea that there are different spheres of influence. and that they should remain completely separate without trying to impinge on one another. So basically, his argument is that science should do what science does, and that should be completely separate and unconnected to what religion does, or if you want to talk philosophy, metaphysics, these other human pursuits, and that they should be separate endeavors, and that they both provide value. And that's one way to approach it. You may or may not agree with that, but read over that, think about it. There's a short question on the reading questions for this day also. So get those, do a very short write-up. In the introduction, I talked about what's expected for those write-ups. So read those and review them. But you do need to understand that science has some very valuable qualities that allow it to really contribute to our society. And science is good for, number one, helping us to test and explain the world around us. Number two, it's self-correcting. If someone makes a mistake, or if someone just outright tries to put one over on the scientific community, lies basically, tries to trick everybody, eventually they will get found out, because science, we can rerun experiments, we can change them slightly, retest, reconfirm. And so science is self-correcting. And hopefully you realize and understand that much of the world around us, modern medicine, modern transportation, our food we eat, our clothes we wear, just about every single aspect of our modern life is built upon these scientific studies, these tests, these endeavors to understand the world around us better, and then refine that, revise our ideas, and come up with better ways to understand and use that understanding to make human life better, I guess. Sometimes maybe not. You could argue it's not always making it better, but to at least understand and then manipulate and change how the world around us works. Okay, so science is really, really good for that. However, there are limitations, and science is not good at other things. So science is not good at, in fact, it plays no role directly in morality. We can't decide what's good or what's bad, right? So we can tell you what we can do, right? So this is maybe the famous quote in Jurassic Park, right? Where Ian Malcolm, the mathematician character in that, says, you were so worried about whether or not you could do it, and he's talking about bringing back dinosaurs from extinction. He said, you were so worried about whether you could do that, you didn't think about whether you should. And we can't run an experiment to see, okay, is this a good thing or this a bad thing? That's something that we need to decide outside the realm of science. So science cannot help us decide morality. It can't help us decide things where there is opinion, right? So fashion is one of those things that I don't understand, and I totally admit that. But there's a lot of subjectivity in that, where someone decides that, this color is what's in this season, or this length of skirt is the fashionable thing to wear. Why? And there really is no good testable reason behind that. It's just, somewhat arbitrary. So science has its limitations, and you need to recognize that. Now, for our U.S. forms of creationism, and again, this is the Judeo-Muslim Christian point of view, there are four basic types that you need to be familiar with, okay? And these are important for our culture, so that's why I'm having you learn them. We could also kind of look at, if we had time, in fact, you do entire courses on this, we could look at the Aztec creation stories, or, a Philippine indigenous tribes creation myth, or whatever it might be. But we're going to learn the ones that are relevant to our culture, and there are four of them that you need to know. The first is young creationism, sometimes called young earth creationism. And this is a very strict interpretation of this religious tradition. And this means that the earth, as we know it, is relatively young. Its age is measured in thousands of years, and that it was created over a very short period of time. The traditional view is 6 days. So that's a very, very strict interpretation of that form of creationism. Gap creationism is a little bit more flexible. It still invokes this idea of 6 days of creation, but it allows for the possibility that those 6 days, may have had long intervening spans between them. So on day one, God does X, and then maybe 300,000 years pass, and then on day two, he does Y. and then 1,000,000 years pass. So that allows for a longer time period for the existence of the Earth, but still is somewhat traditional in that interpretation. Day-age creationism is that instead of 6 creative days, 24-hour periods, that a day may be a figurative term in that tradition, and that a day may represent millions of years or thousands of years. And so that, again, is a little bit more flexible. And gap creation and day-age creation, in large part, were responses to two things. Number one, people began to realize that data seemed to suggest the Earth was much older than just a few thousand years. And number two, many people had realized this before, but this was part of this consideration as these forms of creationism were developed, is that maybe the religious accounts, these religious traditions were not meant to be taken 100% literal, that maybe there's some interpretation and figurative language in those accounts. The final one here is intelligent design. And intelligent design is a form of creationism, but it tries to take God or the supernatural out of the equation. And really that's an impossible thing to do, because even if you say, well, an intelligent being created the Earth, maybe not necessarily a supernatural being, we still really are just kind of pushing the crux of the problem farther away, because if it's an intelligent being, say aliens come millions of years ago and seed life on Earth and start Earth, and they did it in a way that, they designed it and everything was going the way they planned it. Where did the aliens come from, right? So really we have not solved the crux of the problem, which is where did life in the universe originate? So intelligent design is really just a form of creationism. We'll talk about why people would want to try and take God out of the equation in just a little bit. So just be familiar with those forms of creationism. And different people may have different interpretations. Some very traditional forms of religions might have much less flexibility and be young or young Earth creationists. Others may be much more flexible. No matter what your religious belief, or if you're not religious, it's worth a little bit of your time and effort to just understand how these religious beliefs have impacted human U.S. culture is really what we're going to focus on, but we could look at other ones. So the Muslim, Judeo, Christian traditions are all very similar. I have added these links here. You don't need to study them. You don't need to learn anything about them. They are only there if you're interested. So if you want to, if you are a Buddhist, for instance, this is a link, and there are many others, and you can research them. But this is one link of an individual who is a Buddhist and also an evolutionary biologist. And I've got one for Christians, Jews. And so my point is that within these religious traditions, there is often room for both religious belief and religious adherence and rigorous evolutionary biology. You can do both. Now, not every Jewish person or every Muslim person is going to agree with that, or every Christian person. Those who come from more strict or traditional backgrounds might have more of an issue. But again, no matter where you fall on that spectrum, you can read these, you can come and talk to me. It really doesn't matter for the purposes of this class. But what I do want you to do is, no matter where you fall, you keep an open mind. And people on both ends of the spectrum can cause problems in my mind. If you are an atheist, we have people that say this, that say, anyone who believes in any supernatural power beyond what they can measure and experiment on is a fool. And people will say that. I don't think that's a very helpful part of the discussion, but, it's out there. And there are other people on the other end who say, if you believe in evolution, you'll go to hell. And you might know people in your life, maybe even you are falling on one of those extremes. But for the purposes of this class, what I'm going to ask you to do is keep an open mind. It's fine to talk about, to even explore, to come and talk to me about your particular religious beliefs. But we are now in a science class, and science does not negate or completely eliminate the possibility of supernatural. But what it does say is, if there are supernatural forces, that cannot be included in science. Right? In science, we have to be able to measure things. We have to be able to test them. We have to have the possibility of refuting them. And if something is beyond our power to measure and experiment on, then it's not part of science. It doesn't mean it doesn't exist. It just means it's not what science can work with. And so in this class, we're going to deal with data, with experiments, with science. Okay? Now, historically, both creationism and as evolutionary theory became spread and more common, particularly in the early 1900s, often both of them were taught in public schools. And so there were many, many legal cases and challenges to teaching creationism in school. And the basic idea is that in our public schools, which are funded by the government, it is not constitutional for us to teach religious beliefs. That's something that is enshrined in our Constitution, is that we separate church and state. And so if you have a teacher who is essentially a government employee, right, getting up and saying that God did this on this day and he did this on this day, and this is the religious belief, that's essentially the state espousing and taking sides in religion. And so, despite a fairly long and tortured legal history, and I'm only going to emphasize one of these. If you're interested, you can look at more. You don't need to know any more except for this Scopes trial from 1925. But this long, torturous history of legal challenges, and there's still an occasional one, but they're getting less and less common, essentially was resolved in the mid-20th century. And it resolved on two major legal arguments. The first is the one we just mentioned, separation of church and state, right? So that's argument number one. The second one is the non-scientific nature of creationism, is that if you're in a science class, it's not really logical to teach a creation myth that is, or creation story. And I use myth not in the terms of, oh, it's a bad thing. I use it in a more technical term, a technical sense. But the creation story doesn't have a role in science, because you can't test whether or not God did X, Y, and Z, because the idea is that he's using methods and powers that are beyond our ability to measure. Okay, so in 1925, the first major test of the separation of church and state issue came up. And in Tennessee, they had passed a state law saying it was illegal to teach evolution in public schools. And so a man named Scopes did it. He became kind of the test case. There was this long and quite dramatic trial. And this was a time before TV, but radio was fairly common. Many people had radios in their homes and would listen to serials and other radio programs at night. And this trial was broadcast nationwide, and it kind of was the trial of the century, at least the early 20th century, and captivated the public's attention. And so the end result is that Scopes was found guilty. He had broken the law, and really nothing changed for many, many years. Eventually, the Butler Act, which was the law that made teaching evolution in Tennessee illegal, was overturned. And there are many other cases. Some went all the way to the U.S. Supreme Court. Some went to state Supreme Courts. Others were just in more of the regional courts. But all of them eventually relied on these two main tenets. And so today, in our public schools, we don't teach creationism. Now, if you're taking a comparative religion class or history of religion, maybe you learn about it there. But we don't get up and say, God did this, or at least we shouldn't. And there that becomes a problem, right? If you are a believer in the Constitution, following the law of the land, then teaching that in our public classes is a bit of a problem. So just know those two major things that have now resolved itself. So we teach the data, the science, the testing in our public schools. Now, in private schools, right, at home or in a private school funded by private individuals, it's a free country. You can teach whatever you want. But in our public schools, creationism is not part of the scientific curriculum. Okay, so there are those two arguments. Just review those, go over those. If you have any questions, particularly for your individual beliefs, or if you want to talk to me about that, I'm happy to do that. Send me an email. Jump into one of the Zoom sessions. That's a place where we can do that if you're interested. Okay? But we are studying science, and we are hopefully scientists in this class. And so you need to understand the importance of evolution. It plays a key role. In fact, it, along with cell theory, is one of the two foundational elements of biology. Okay? Really, all of biology is, I almost said falls apart, but the idea is that we can't fully understand biology unless we are also understanding the evolutionary history of organisms. It provides a roadmap, a context for all of the data that we gather and everything that we see in biology. So it really is a key foundation for all of the study of biology.